This is a number line, the simplest example of a coordinate system. For each point P on the number line, its coordinate is defined as the signed distance from P to O, the origin. Therefore, every point on the number line corresponds to a real number, and every real number corresponds to a point. Even though this image explicitly shows only the whole numbers from -5 to 5, the line represents all the real numbers, continuing infinitely in both directions. So how can we have a glimpse of the entire number line? By simply zooming out doesn't help. We are talking about reaching infinite in a finite screen. This reminds us of the tangent function. Well, this part of it. See, tangent of x goes from -infinity to positive infinity when x goes from -1/2 of pi to 1/2 of pi. Now every point on the y-axis has a corresponding point on a small region of the x-axis, pi units in length to be specific. This way, we can squeeze a number line into a finite space. Well, pi is the circumference of a circle with a diameter of 1, so we can wrap this line segment around to make a circle. For the sake of demonstration, let's double it to make a unit circle. Now every point on the number line has a corresponding point on a circle, and every point on a circle, well, not exactly the same. This specific point on a circle, so-called projection point, is missing, simply because the tangent function is neither defined on -1/2 of pi nor on 1/2 of pi. But since the left limit of the tangent function at 1/2 of pi is positive infinity, and the right limit at -1/2 of pi is negative infinity, we can regard the projection point as the infinities. You must have noticed that these 3 points seem to line up, and this is true. Here's the proof, and you can pause to observe it. What we get now is a mapping that associates the points on the unit circle, missing a point of course, with those on the line. It seems that there is a light source at the projection point projecting the circle onto the line. Now, let's change our view to the 3-dimensional space. Similarly, every point on the plane has a corresponding point on the unit sphere, which is obtained by drawing a line that passes through the projection point. This way, we can project the sphere onto the plane, and this is called stereographic projection. As a result, every ordered real number pair is associated with a point on a finite shape. Let's have a closer look at this plane. Well, just the plane itself is a little boring. We can put a graph of some functions on it so that we can have a look at the parts that are usually outside the canvas. Let's start with something simple, y equals 2x minus 1. Which set of points on the sphere would correspond to the points on this line? A circle. In fact, a line on a plane always corresponds to a circle on a sphere that goes through a projection point. Note that if a function approaches infinity, we can think that the corresponding curve on a sphere goes through the projection point. What about this inverse proportional function y equals 1 over x? An H-shaped curve. In a coordinate system, the curve has 2 separate parts, but it is continuous on a sphere. This is the curve for y equals x squared minus 2x. E to the x. Sine of x. Cosine of x. Tangent of x. And this is the normal curve. That's enough for functions. Let's take a look at conic sections. A conic section is the set of the points whose distance to a fixed point, the focus, is a constant multiple, the eccentricity e, of the distance to a fixed line, the directrix. For e between 0 and 1, we obtain an ellipse. For e equals 1, a parabola, and for e larger than 1, a hyperbola. Therefore, we can fix the focus and directrix and change the eccentricity. You can see that when e goes from 0 to infinity, the graph goes from the focus to an ellipse, to a parabola, to a hyperbola, and finally to the directrix. What would be the inverse image of these curves on a sphere? See, it is smooth and continuous. No matter a line, a plane, or a space, they're infinite. But it doesn't mean that infinity is their edge. Infinity is not where everything diverges, but everything meets. Infinity is not the end, it's a brand new beginning.